So welcome to this class on natural language processing and text mining. This class starts today and will continue until the end of March. We will have three main threads: linguistics, symbolic methods like formal grammars, logic, ontologies, and so on, and machine learning methods. We will start today also a lab on chatbots. So today and next week, you will discover two systems for creating chatbots. And during this class, so until the end of March, you will work on a chatbot of your own. And this will be your project, which you will send me at the end of the class. And there will be two examinations, a very short one on February 24th, only half an hour, and the final examination on the last date, so March 24th. And of course, I will give more details on these examinations later. So today, as you see, February 3rd, we will start with the thread of linguistics. If you have any questions, if you don't understand something, don't hesitate to interrupt me. I start with slide on terminology. In French, there are two words, langage and langue, meaning different things. So langage is much more general. Langage is a structured system of communication. So it must be used by humans, and it can use sounds, written signs, or gestures. And all we ask is that it is structured. While langue is a language, so a structured system of communication, but one that has evolved naturally through use and repetition. So we don't know exactly when it started, it evolved, and it arrived at a status today. Langue is a system that allows to express, to communicate any kind of message. So it's a general purpose system. And often langue, so in English, natural languages, are used in, have official status as the languages of nations, of countries, of regions, and so on. So this distinction between langage and langue exists in all Romance languages. So in Italian, linguaggio, lingua, in Spanish, lenguaje, lengua, but not in other languages. And in that case, we use the adjective natural. So this is where we distinguish langage de programmation, but langue bretonne, and langue de signes sign language is a langue and not a langage. Okay, so this is just for terminology. Now, the first important thing to consider when you study natural languages, but also other kinds of languages, is the principle of compositionality. So this principle says that you can take objects without meaning or with very limited meaning, and you obtain meaning when you compose them. So, for example, what we call second articulation. You can take letters C, A, and T Each one of these letters has no meaning, but when I compose them in the sense of concatenation, when I put them side by side, I get the word cat. And first articulation is one level higher. When I take just words, the word cat, the word sleeps, and the word thee, so each word has a meaning, but if I take the word alone, I don't get a message. So to get a message, I have to compose them, to combine them, to concatenate them. So this sentence, the cat sleeps, is a composition of objects at the level of words, and each word is the composition of objects at the level of letters or sounds. And these two phenomena, second articulation, first articulation, are present in every language. So this is a global phenomenon, and this is how language works. Linguistics has many strata, and we will study them in order of lower complexity to higher complexity. So we will start with objects as simple as sounds or graphical marks, and we will move up, as we did here with second articulation, first articulation, we will move up to morphology, syntax, semantics, discourse analysis, and pragmatics. So this is not my invention, it's the legacy way of studying a discipline with many strata like linguistics. So we will start with graphemics and phonology. So my first section today is about phonetics and phonology. Yes? No, I thought there was a question. No. You can also use the chat. I have the window open in front of me, and I see we are 27. That's good. Okay, so let's start with phonetics. There are different kinds of phonetics, and what is interesting is that these different kinds of phonetics belong to different scientific disciplines. So these are different ways of studying the same phenomenon. For example, articulatory phonetics studies how speech organs work. So this is part of physiology, which is a subdiscipline of medicine. Acoustic phonetics study the sounds when they are transmitted. So this is part of physics. Perceptive phonetics study the way humans perceive and distinguish sounds. So this is part of psychology. And finally, phonology is the study of the transmission of meaning by the use of sounds. And this is a part of linguistics. And of course, this is which will interest us the most. Now, articulatory phonetics is useful only to see why we have so many terms, so many different classes of sounds we will use, which we will call phonemes in a while. And this is because of the building of the speech organs. You have many muscles at many positions, and it works a bit like a machine. Here in this diagram, you have a comparison between the actual organs and the way they work. So here you have air going up, and you see you have pistons, valves, and here you have the tongue, which will move, and different parts of this channel will get broader or narrower. And depending on the place where we will make this channel broader or narrower, we will have different kinds of sounds. And all of these names you will see used in the description of these sounds. Now, for example, if we take the three fundamental vowels A, I, U, when you pronounce an A, your tongue is low and you leave space to air. When you pronounce an E, the tongue is near the cavity, and when you pronounce an U, the tongue is high but on the back of your mouth. So these are drawings, but here you have X-rays and with the 5 fundamental vowels, E, A, O, U. And that proves the different positions of the tongue to obtain the different vowels. A way to study vowels is to use frequencies. So these are the various frequencies that are generated when we pronounce E, U, A. And as always, you have a fundamental frequency, but also harmonics. We call the two fundamental harmonics formants. We call them F1, F2. So this is something a machine can very easily identify. So you emit the sound and the machine can immediately tell you what is your fundamental frequency and what are your harmonics. Now, if you look at the harmonics F1, F2 for the three vowels, you will see that in the case of E, F2 is high, F1 is low. In the case of U, they are much closer, but F1 is still low. And in the case of A, they are very close, and F1 is higher than in the case of A, E, and U. And here is the representation of the relations between F1 and F2. Here you have frequencies. These are hertz. This is F1, this is F2. And we can position different vowels according to the frequencies of F1 and F2, and we get what we call a vocalic triangle. So this works for every language. Here we have the example of French. Here you have the symbols of the International Phonetic Alphabet for these sounds. And in blue, you have words in which they appear. So here you see the difference between mère, né, ni, œuf, je, mu, mode, mot. So you see these two are written with the same letter O, but still the pronunciation is not the same. Mode, mo, nu, pat, ba. We can do the same thing for consonants. And here, of course, the table is much more complex because you have here the way they are produced and here the position where the sound is produced. So the production can be labial, the lips, dental, teeth, palatal, palate, velar, pharyngeal, pharynx, so the throat, and so on. Here you have the symbols in the International Phonetic Alphabet. So this is international. And I tried to give examples for most of them. Most of the examples are in French: po, bo, na, to, do, signe, qui, who. In many cases, I had no example in French because the sounds do not appear in French, like theta and delta. And so sometimes I used Spanish words like junto, German words like Licht, or Arabic words like ha, ein, ha, rein, and so on. Now, to make this study more systematic, linguists have used features. And as we have many features, so this is just a small samples, there are much more features. By giving a binary value, feature exists or doesn't exist for a given sound, we can distinguish all of these sounds. So while here you have something which is continuous because the tongue is moving in a continuous way. So this is analogical. Here you have something binary. Either you have the feature or you don't. And the combination of features describes all of these sounds. And this goes for consonants and also for vowels. Now, we will call these sounds phones. But in fact, there may be differences in phones of which you are not conscious. So for example, in French, you have the two words qui and coup. Most people think that this is the same sound, but in fact, this is a palatal qui, and this is a velar ku, qui, ku. So try to pronounce them, you will see that your mouth takes an entirely different configuration, and it's not the fault of the vowel E and U. These are really different phones. Now we call these allophones. So an allophone is a phone used in a given language, but which is not discriminative. So people are not conscious of using these two sounds. In other languages, these two sounds are significant. So their difference is significant. And in the Devanagari script, which is used for Hindi and Sanskrit, you have different letters, different graphemes for them. And the use of different phones in languages makes us dependent of the languages we speak, and most of all of our mother tongue. And this is why French fans have difficulty pronouncing some words like think, because there is no phone th in French, and this is of course symmetric. Englishmen have difficulties in pronouncing French vowels or nasal bienvenue will sound like bienvenue. So this is because of the difference of phones in languages. Now, saying that different phones are used is not sufficient to make a systematic study. One of the most important ideas in linguistics was, so this happened in the 20s, the idea of minimal pairs. So this idea says that two phones are allophones if there is no pair of words in which, if you exchange them, you get different meanings. Another way of saying this is whenever I can take a word, change one sound and get a different meaning, this means that the two sounds, the original one and the exchanged one, are significantly different. And we will say that they belong to different phonemes. So here are some examples, again in French, sou and chou, ton and mon. So te and me are different phonemes. S and sh are different phonemes. Pat and bat, pe and be are different phonemes. And here these examples are all chosen because these phones are different in French, but not in other languages. So people native speaker of these other languages sometimes have difficulties distinguishing them. Vas, baz. So in Spanish, distinction between v and b is not very clear. In Arabic, there is no p, so p and b are difficult to distinguish. In Breton, there's a problem between t and me. So what we call phonemes, and this is the first very important concept we learned today, are equivalence classes of phones. Equivalence in the sense of when you stay in the same phoneme, your word cannot change meaning. And here are some examples. As we said, in French, you have qui and coup. Different phones, same phoneme, written in the same way, qui, coup. In German, you have acht and licht, ch, ch. Two different phones. Here are the symbols, but the same phoneme. In English, you have paper and spill, p, p. Different phones, same phoneme. Now, the number of phonemes needed for a given language is not very big. Sometimes it's about 20, it may reach 30, sometimes 40, but never more than that. While the number of sounds the human can produce is much, much higher. And when you have dialects, often some phonemes are merged and other distinctions appear. And so the global number of phonemes remains the same, or more or less the same. Phonemes are very interesting because they are really characteristic of a given language. And the study of phonemes is called phonology. Now, once we have defined phonemes, comes the second part: how do we deal with them? How do we study them? One of the branches of phonology, which appeared in the 60s, is generative phonology. Generative in the sense that the principle is one defines rules called transformation rules, and with these rules, one can generate all words of a given language, or all acceptable word forms of a given language. So when we say generative, and we will see this in other areas as well, it is always meant that there is a grammar with rules, and using these rules, you can generate a language. Here, generative phonology starts with phonemes, and applies transformation rules. And whenever you apply a rule, you get what we call a level. So you start with the lowest possible level and you go up until the surface level, which is the rendering, the phonological rendering of a word in the given language. So let us take an example. Now, you know that in French, sometimes you have the liaison. So you say mauvais été, but mauvais travail. So here you have a the, mauvais été, and here mauvais travail. How can generative phonology describe this phenomenon? So we will write mauvaise été travail in phonetic alphabet. And we will say that mauvaise is our underlying form. And now, in the presence of été, we want to move to the surface form of this word. And generative phonology says you will apply rules. One of these rules is truncation. The rule says a final sonorant is truncated in front of another sonorant. Sonorant consonants being these here. Not all of them, but here's a good list of sonorant consonants. Now, what happens when you have mauvaise travail? Well, Z is a sonorant consonant, T is a sonorant consonant. So the rule says we truncate the first of the two words and mauvaise becomes mauvais. Okay, now what happens when we have the feminine form? Now, generative phonology says we will add this sound schwa, so the E muet, to the masculine form to obtain the feminine form, mauvaise, mauvaise, E. But when the word is isolated, you would say mauvaise, but if it's followed by trouvaille, you would say mauvaise trouvaille. So this E disappears. So this is another rule. This rule is called Schwa Removal. Schwa is the E muet, and the schwa is removed in front of a sonorant consonant. So you start with mauvaise trouvaille, and by applying the schwa removal rule, you get mauvaise trouvaille. Now, the idea of generative phonology is that these rules are all applied to all words, but in most of the cases, they are inapplicable. So we have this algorithm where we have a list of rules in a given order. These rules transform the underlying forms until we get the surface form. And this happens in our brains as well as when machines do what we call speech generation. So when computers speak, they generate speech, and they do this, they apply this rule. So this is the approach of generative phonology. Now, if we want to move up, phonemes are grouped together and form syllables. Now, syllables can be detected by their intensity. Compare il est ouvert and il est ouvert. So il est ouvert, il est ouvert. In both cases, the phonemes are the same, but by the intensity, I get a division in syllables, which is different. Here I have the syllable tu, and here I have the syllable et and the syllable u. In all languages, syllables have a start, which is called onset, in French attack, and a rhyme, so the rest of the syllable. And this rhyme consists of a nucleus, so a kernel, and potentially a coda. So for example, in the word poésie, I have 3 syllables. In po, peu is the onset, o is the rhyme, which has only the nucleus, or e has only a vowel, and z has consonant and vowel. And in strict, you have again a single syllable, which has, as you can see, many consonants and a single vowel. And then you have rules about syllables. So for example, in Arabic, a syllable can never start by a vowel. Therefore, you have the glottal stop hamza. If you want a long vowel, starting a word, you start with hamza, which is a consonant. Syllables can have tones. So tone is height of the sound. So it's measured as frequency of your sound wave. And 70% of the world's languages are tonal. So they use tones.
Excuse me?
Yes?
Can you explain again the previous slide about how a syllable is built with you said, so there is an onset, and in poésie, the onset is po, and then az, what is it? Is it the right?
No. In poésie, you have 3 syllables, po,
okay.
e, and z. The onset is the first consonant. So p is the onset of po, and the vowel that follows is the nucleus. You always have a nucleus. So a syllable has at least a vowel. And often also consonants. When the consonants come before the vowel, they are called onset. When they follow the vowel, they are called coda. And okay. Strict is a single syllable where you have s, t, which are the onset, e is the nucleus, and t is the coda. Okay, and these are phonemes, not phones. So syllables are defined in a formal way using phonemes. Okay. I was talking about tones. So when you have different tones, you keep the same phoneme, but you pronounce it either at a different height or at varying height. As you can see here, you have the 6 tones of Northern Vietnamese, and there is the high tone, the low tone, and the acute grave, and also this varying tone, which goes down and then up again. And here you have 6 syllables with the same phonemes, but different tones, and as you can see, completely different meanings. And same thing in Chinese. Maybe Tian can pronounce these words for us. If she's listening. So this is simplified Chinese, this is traditional Chinese, and you have the same syllables with different tones and therefore also with different meanings. No, he's not listening. Okay, next time I will prepare a sample. And same thing in Thai. Now, tones are an example of properties which are not specific to phonemes, but to group of phonemes. And we call these suprasegmental properties. And there are basically three kinds of suprasegmental properties. There is duration, so how long does it take? It's measured in seconds. Intensity, so how strong is the signal, measured in decibel. And melody or intonation, which is how high is the sound, which is measured in hertz. And if we take these three together, we get what we call prosody. Now, prosody is very important, especially for computing, because this is how a machine would detect emotion, question, and many other characteristics, and also will reproduce them in speech synthesis. Now, melody, intonation, is also subdivided in three properties: register height, so how high are we? Curve direction, are we going up or down? And curve form, are we going up or down in a concave or in a convex way? And this illustrates the way we have to represent intonation. So what you see here is the frequency. So this is in hertz. Here you have a sentence. Jour, en lisant le journal des sorcières, elle tomba sur le communiqué suivant, Madame. And this is a tool called Prat. It's free, so you can download and use it. And it will segment speech, so recorded speech, into phonemes, words, and words represented as phonemes. And on the same temporal axis, you have the intonation, so the change of frequency depending on each phoneme. So you see, for example, here the E of sorcière, how, and the yellow one is intensity, I think. So intensity goes up and down again with the sorcière. And this allows speech recognition and also allows extracting many useful level of information from speech. And here I give an example of the data we obtain from Prat and SPPAS, a French program, also free. So what you get is, for every phoneme, the interval in seconds and parts of seconds, so milliseconds. And then the same thing with words. So now you have the exact duration of every word, and here of every phoneme. And it also gives you the intensity, F1, F2, 4 months, and so on. Here is an example of insistence detection. So how intensity and frequency can allow the machine to detect insistence. So here you see you have a repetition, es exquisito. A mí este perfume me parece exquisito. So the second time this word is pronounced, it's much more insistent, and the machine can detect this. And here you have a very interesting table with different emotions and the way they are detected or reproduced when you're doing speech synthesis through prosody. So the lines are different characteristics: speech rate, so how fast do you speak; pitch average, so how high in average; pitch range, so do you really go from low pitch to high pitch; intensity; voice quality, so this is more about the characteristics of the voice; and pitch changes; and articulation, how well do you articulate, and the different emotions. And you can see again, through this table, you can distinguish them. One thing I didn't said is on the slides, you have IDs of bibliographical references, which are all on Moodle. So it's on the bottom of the page. I have a file, bibliography, where you will find all the references. And you can look, you can search this key and find the reference, which is in BibTeX format. So whenever you see interesting tables or illustrations or facts, I always have a reference where you can go and read further. Okay, so this was all I had to say about sound production. And now let's switch to written language. So we call the disciplines involved in the written language graphetics and graphemics. So graphetics is the equivalent of phonetics. Graphetics is the study of the materiality of writing. How do we write? How do we draw signs which are intended to be read, which are intended to be part of a linguistic message? So it's not drawing in general, it's drawing with intention of using the written form of a language, either natural or artificial. And graphemics is like phonology. So in graphemics, we formalize, we search systematicity, and for a very large number of signs studied by graphetics, we want to keep a small number of graphemes in the same way as phonology keeps a small number of phonemes. And we will go into detail about all that. We have two special cases of graphemics. The one is typographemics, which deals with typographical text. And the other one is Cyanographics, which studies the Chinese writing system, which is a very important writing system used in Chinese, Japanese, in Korean, less and less, and was used in Vietnamese until 1910. Now, graphemics, unfortunately, is not considered as being equally important as phonology by most linguists for historical reasons. And today, there are three approaches, three attitudes versus phonology. And these are three different ways we can deal with written language. The first one is called phonocentrism. Phonocentrism, which is a very widespread ideology, is that only speech deserves to be studied, because speech came first and writing came second, because many peoples have no writing, they communicate only by speech. So these two arguments are used to say that writing is less important than speech. The second attitude, phonographism, is that speech and writing both deserve to be studied, but speech comes first. And writing exists only to represent speech. So if you go to the Wikipedia page on language, in the Lemma language, it says there are languages use sound and gesture, and some of them have written representation. So this is a phonographic attitude towards language. And the third approach is autonomism, which says that they are both equally important. Spoken language, written language are equally important and can be studied independently. Now, let's take an example of phonographism. So Nina Katash, who was very involved in orthography planning and orthography reforms in France, considered that we have three kinds of phonemes: phonograms, morphograms, logograms. So phonograms are those that represent phonemes. So for Nina Katash, this is a grapheme, G, like in garde, and this is also a grapheme, G, like in ge. And therefore there is no grapheme Q, but only QU. Morphograms represent morphemes. We will define morphemes later. It's the minimal unit of meaning. And here, for example, in the word ronde, I have three phonograms, R-O-N, and two morphograms, E, which is the suffix of the feminine, and S, which is the suffix of the plural. So these two have a special meaning. They carry a grammatical meaning, and therefore are called morphograms. And then logograms for Nina Katash are words written in a specific way to be distinguished from their homophones. So for example, pou, you have also pou, the flea, pou, the pulse, coin, you have the angle, coin, and the fruit, coin. Well, they are written in different ways to be distinguished. And Nina Katash calls them logograms. Logograms because the word contains a specific meaning, and the way it is written communicates that meaning. Now, Jacques Anis is introduced autonomism, and he defines alphagrams, which are similar to phonograms for Nina Katash, but here we are taking only the written part. We are not interested in phonetic representation. We do not care about how things are pronounced. We only care about what is written. So alphagrams are building words. Topograms are spaces or punctuation or styles. So they regulate first articulation. So they represent syntax, or they modify alphagrams by different styles. And logograms are equivalent to sequences of alphagrams. So for example, a, paragraph, dollar, euro, all of these are logograms. They carry a specific meaning. So these are the three kinds of graphemes for Jacques-Anise, and he distinguishes nodes among alphagrams. He distinguishes nodes and sat. So nodes are kernels of graphical syllables, what we call in phonology vowels, and sats are like satellite, are those around the kernels, and in phonology these are called consonants. Sorry, in phonetics they are called consonants. Now, this may sound a bit trivial, but in fact, Jacques-Anise starts with written text. So he forgets completely the phonetic representation. He doesn't pronounce. He just takes the written text as if we don't know how it is pronounced. Imagine some ancient language or some extraterrestrial language of which we don't know if there is an oral version and how it works. And he defines these nodes and sat in a purely frequentist way. So without looking at the oral part at all. And 2 years ago, two Canadians, Thane and Penn, have used statistic methods on written text and have shown that by using these methods, one can rediscover vowels and consonants. So here you see the French graphemes, so the letters of the alphabet, and using this method by Thane and Penn, we have the vowels, which are completely apart of the consonants. And between the two, we have this Y, Y in French, which is in fact a semi-consonant. So you see you have vowels, consonants, and in the middle, semi-consonants. And this is done purely statistically, without any linguistic information about how words are pronounced. So the method of Anise works, and we can rediscover consonants and vowels using only written texts. And so, for example, if we find texts from some lost civilization, by using this method, we can say which symbols belong to consonants and which symbols belong to vowels, if, of course, we admit that it is an alphabetic or Abugida writing system. So a writing system which represents consonants and vowels. Now, the theories of autonomism by Anise sounded a bit extremistic at that time in the 80s, but today, with the internet and globalization, we have more and more tendencies of using the written language as the most important communication vector. So the internet is mostly written. You have, of course, videos and sound, but most of the information is in written form. And here you have an example of a book which by a Chinese artist called Xu Bing, called From Point to Point, and published by MIT Press. It's a 128 pages book using only pictograms. As you can see, it narrates a story, the story of a day of the narrator. Here you can read, I opened the door and I saw a man from Amazon, and the man gave me a package. I said goodbye, the door closed. So you see arrows denote temporality. The door was open, it becomes closed, period, new sentence. I take the package and I open it, and from inside, I take a book and I open the book, comma, and I'm happy. I read, ellipses, so 3 dots, time passes, coffee, so more time passes, the eye looks at the book, so I'm reading, and so on. And this way you can read 128 pages. And this book has been translated into French. You can buy it in French. And of course, the only thing translated was the title, which is the only part of the book in using alphabetic script. And as you can see, it uses pictograms, but also heavy punctuation, arrows, parentheses, commas, and so on. And this, of course, has absolutely no phonetic part. Everyone can pronounce it in his or her own tongue, and it is independent of phonetics. Now, like we had generative phonology, we also have generative graphemics. So Richard Sprout has introduced this theory of generative graphemics, saying that what generative phonemics says, where we have the underlying form, where these are abstract sounds, as generative phonemics says, using transformations, we get speech. And now Sprout says, okay, I can take this underlying form of phonemes, do a conversion, and I get graphs, and applying a different set of transformations, I get writing. So I have this diagram where from the same source, I get both oral and written language. And here's an example, again in French. I have abstract sounds for du. Now, this word du is the plural of du with a circumflex accent. So I own something. Je dois quelque chose à quelqu'un, donc c'est du. Les objets du with an S. So I have the S of the plural, and du, which is the past participle of the verb devoir. Now, the transformation using truncation will say, okay, there is no need of liaison, so the S disappears. So this is the transformation we saw already. And so the pronunciation of this is, the surface form is du. Now, then when converting this into graphemes, I get DUS, but then I have a transformation, which is how do I distinguish du, the article, the contraction of de le, and du, the past participle of devoir, with a circumflex accent. So this circumflex accent is only there to disambiguate the word du in the singular, and we keep it in the plural. So this circumflex accent is added by a rule of disambiguation, which is specific to French. And this is why we get this phonological surface form and this graphemic surface form, according to Sprout. Now, a way to classify the use of graphemes is what we call writing modes. Some decades ago, people would classify writing systems according to these writing modes. But this was a bit Eurocentric, a bit colonialistic. Well, they were wrong because every writing system can use any one of these writing modes. So these writing modes are the pictographic mode. The pictographic mode is when your drawing resembles graphically to its referent in the real world. So this is a man. Well, it looks like a man with two legs. This is a river. Well, you have three straight lines. It's like water flowing. This is a mountain. You have three lines. The middle one is higher, so there's a mountain. And this is a cup of coffee. And this is a happy face. So these are pictograms. You have the logographic mode. In the logographic mode, a grapheme has a specific meaning. It has a complete meaning, but it doesn't resemble graphically. The meaning is abstract and there is no resemblance. So this is and, this is copyright, this is euro, and most of Chinese characters are logographic, are used in a logographic way. Not always, we will return to this. Then you have the syllabic mode. Each sign represents a syllable. So both consonant and vowel, and sometimes a third consonant. And this is the case in Japanese kana, in Korean hangul, and so on. Then you have Abugida. So Abugida is used mainly in Indian languages. Hindi, the writing system is the Banagari, Tamil, and Bengali, and the Gujarati, and so on. In Abugida, every sign represents a consonant. Sometimes we add a sign to indicate a syllable, so a vowel. But if we don't add any sign, then we have a default vowel, which is A. So when you see the simplest form of the sign, it is pronounced with the default vowel, which is A. And when you add other signs around it, you get other vowels. So it becomes syllabic, but it has a default form. Another writing mode is abjad. Abjad is used in Arabic and Hebrew. In abjad, we write only consonants and long vowels. Short vowels are not marked explicitly. They can be marked, there are special symbols for that, but usually they are not marked at all. So when you see a consonant, even though there is a syllable pronounced, you don't know the vowel of that syllable, and you have to detect it. And there is software, there are algorithms, more or less successful, to detect from the morphology, the syntax, semantics, and so on, to detect the short vowels. And it's called abjad because in the Arabic numbering system, you take the A, alif, the ba, the jim, dal. So these are numbers, and so these are letters of different shape. So they are not distinguished by the number of points, but by their shape. And by taking them in order, you get A, B, J, abjad, dal. And alphabetic mode is when you mark both consonants and vowels by separate signs. Now, don't get influenced by colonialistic ideologies saying that alphabetic is the best writing mode. This propaganda was very widespread in the beginning of the 20th century. Today, we recognize, and it's undoubtful that all writing modes are equally important and all are used, and many of them are used in writing systems. Now, for example, here are some examples to show that even French is not always alphabetic. When you write this, cassette, you're using a syllabic mode because you take not que, but ka, the name of the letter, and set as a syllable, the name of the number, the two syllables together, cassette. So you don't care about the meaning of set, number 7, you only care about the pronunciation as a syllable. When you write this, it's a pictographic mode because it looks like a face. And when you write this, it's logographic because you take a letter, you write it in a very specific way. So this is a graph more than a grapheme. And this letter is pronounced phi, and phi are the initials of a political party, F-E. Now, in the remaining 5 minutes, let's talk about typographemics very shortly. As we said, typographemics is graphemics in the context of typography. And here, graphemes do not come alone, they come in boxes. And these boxes have dimensions, and these dimensions originate from metal typography. So we have body size, set width, and we have an imaginary line called the baseline. And this baseline was used to place the types on this device and to print. Now, as they are placed here, these graphemes or typographemes interact. They interact by kerning and ligatures. Now, let us take these two examples. Kerning, so kerning in French crénage, is the distance we allow between letters or signs. And ligatures are cases where two graphemes merge to form something new. For example, here you have a ligature, FL, and here you have no ligature, FL. Here you have kerning between A, V, and A. Here you have no kerning. Now, it may seem that these two properties, kerning and ligature, are only aesthetic ones. In most of the cases, they are just aesthetic. So it looks better when letters are kerned. It looks better when F and L are merged to form a ligature. But in some cases, these phenomena, or better said, the absence of these phenomena carries meaning. So here I have the example of two German words, which are both compound words. So they have components. Auflage has compound auf and Lage, which is the addition. Querflöte, quer and Flöte. So it's the flute, it's a traversal flute. And here, the F is the last word of the first component, and L is the first word, first letter of the second component. there is a rule saying that between components, we don't want ligatures. So these two letters are not allowed to merge, while here, F and L belong to the same component, so they can merge. And this allows a better reading of German. So this represents the structure, the morphological structure of German language in a more efficient way. Same thing here. So this has nothing to do with German. If you don't put kerning, then these three letters are read like different symbols. And for example, they can be mathematical variables. So this can be the product of A, V, and A. While here, by kerning them, the eye recognizes them as being the same word, the word Ava in capitals. No, last slide before the break. In the last 2 decades, there are more and more uses of what is called gender-neutral language. So gender-neutral language omits information on gender for many reasons. We don't want to prioritize, we don't want to address one of the two genders or one of the many genders, because genders are not necessarily binary. And among gender-neutral writing language, you have writing. And how can writing become gender-neutral? It can be in a lexical way. So we choose words which are specifically gender-neutral. So here I have some examples. In English, instead of writing he or she, write E. Instead of writing him or her, write M, and so on. So this is just only one proposal among many, but there is a Wikipedia page for this, and I use it frequently. Interestingly, in French, German, and other languages, you have methods that are not lexical, but graphemic. So it's on the level of graphemes that we use gender-neutral language. In French, this is called écriture inclusive. Écriture inclusive uses this special graph called point milieu or point médian, and we separate the stem of the word of the suffix of the female of the suffix of the plural. So if we want to use the plural, otherwise we just take this part. And by doing this, we mean both male and female. In German, this method is called the Binnen-I. So in German, we use the feminine form with a capital I in the middle of the word. So by writing the aufmerksame Studentinnen, it's the female, these are female students, but by capitalizing this letter, we indicate that we mean both male and female. In Spanish and Italian, there is a very specific phenomenon to these languages, which is that most masculine adjectives and nouns end with an O, and the most feminine with an A, O or E, and A. By using this symbol, we avoid the letters indicating masculine or feminine gender. So this can be read los progenitores, ragazzo italiano, or ragazza italiana. And here, the way of writing is completely independent of pronunciation. So there is no way of pronouncing this directly. I can only either choose between masculine and feminine or repeat, use one gender and then the other gender. And in Greek is a method similar to the French one where the feminine or the masculine suffix is added to the other one. And here this QR code is about a presentation I gave a month ago about all the details of these methods. And these methods, of course, have good intentions, but they are not perfect. And these pictures show some of the problems. For example, the rules are not very clear. If you take the word tu, tut, it's not clear where to put the special character to indicate gender neutral writing. And in fact, the rule is you process singular and plural separately. So in singular, you have tu, T-O-U-T, tut. So you put the point médian between T-O-U-T and E, while in the plural, you have tous, tout. So you will put the point médian after the U, T-O-U, then the female, T-E, then again point médian, S. So this here, what you see here is correct. The upper picture is correct. In the lower picture, this poor guy didn't know where to put the point médian. So he used 3 point médians just to be sure to put it in the right place. But you can see that this one is heavier than the other two, which shows that he was badly influenced and he put the heavy one at the wrong place. And in German, the problem is that this capital E is not very visible. So here you have very narrow letters, Friedhofbesucherinnen, visitors of the graveyard, and this is almost invisible. So it says no parking except for visitors of the graveyard, and you have the impression that only women are meant by this sign. Okay, so now it's time to take a break. It's 10:51. We have a 15 minutes break, so I suggest we start again at 11:10. So see you in 15 minutes. So we stopped in the middle of graphemics and phenomena which are specific to typographemics. So two other phenomena are hyphenation, in French césure, and non-breakability, so the fact of not breaking, in French insécabilité. Hyphenation is the fact of segmenting words, cutting words at line end. This is really necessary, especially for languages like German or Malagasy or Russian with very long words. Now, every language has a different approach to hyphenation. It can be purely phonetic, like in Italian, where you see it's in, te, ra, even though etymologically you have interazione. It can be a mixture of phonetic and morphological, like in French, where you have interaction. It can be grammatical, where in English we will separate the suffix. It can be lexical, like in German, where we separate compounds, ein, aktig. It can be authorized everywhere, like in Chinese, except in front of punctuation. It can be strictly forbidden, as in Arabic. And in classical Hebrew, and it can be variable according to origin. And Yiddish is a German dialect written in Hebrew script with many Hebrew words. So one hyphenates or not, depending on the origin of the word. And interestingly, the French word conscience cannot be hyphenated because you cannot cut CE, it's too short, and you cannot cut con because people will read this word and think of something else. Now, in German, you have different levels of hyphenation and which will be prioritized. So, for example, in a compound word like wahrscheinlichkeitstheoretische, so relative to relativity theories, you have places between components which are used in priority, and then inside components, so inside the last component, and finally, only if absolutely necessary, inside previous components other than the last. And in German, you also have, or at least had before the orthographic reform of 1996, also transformations where words were hyphenated and changed during hyphenation. So Backen would be written with a K instead of a C. Betuch would be written either with two T and a T or with one T and a T, depending on its meaning. Schiffer, there would be another F appearing, and so on. Now, I told you that different languages have different approaches to hyphenation. Well, the word used for hyphenation often gives also the attitude of that language. So, for example, in German, it's Worttrennung, separating words. In English, it's hyphenation, inserting a hyphen. In Spanish, separación, so separate syllables. And in Italian, it's really syllabazione, so syllabification. Same thing in Greek, syllabismos. So in these languages, we are interested in syllables, while in German, for example, we are interested in words and components. Non-breakability is used, for example, to distinguish this abbreviation dot M. Martinet, Monsieur Martinet, from this period, which is a sentence full stop. So here you are not allowed to break, here you can break. Now, hyphenation is something specific to typographemics, and non-breakability is also specific to graphemics, but there is something similar in phonology, which is related to breath. So do we keep our breath, or are we allowed to breathe between words? So this seems to be secondary in most languages, but in some cases it is forbidden to breathe between words. And this is part of the Quranic recitation symbols. So in the Quran, you have symbols saying here you are allowed to breathe, here you are not allowed to breathe. If you breathe, then you change the meaning. Okay, so I'm giving you these examples to show that there are cases which seem secondary, which seem details, but in fact, they have a linguistic role, a linguistic function, which has not been studied yet thoroughly. In typographemics, you work with oppositions. So an opposition is a binary choice. For example, you can choose between straight and italics, regular and bold, lowercase and small caps, Roman sans serif, and so on. This is a bad example. This is not really sans serif. Sorry, I will correct that. Variable width, single width used for computer code, normal spacing, lettering. Lettering means getting individual letters farther apart, which one normally avoids, except in Fraktur German, where you have no other means, you have no italics, you have no bold, so you use lettering, like here, manchmal wirklich nötig ist, to emphasize. You have exponent and subscripts, like in French for premier, première, deuxième, and all ordinals, abbreviations like madame, mademoiselle, monsieur, maître, docteur, and so on. And you can also use body size to indicate, for example, fading and so on. So these are the many tools you have, which can have denotation, so they can complement your, or rather supplement your meaning. They add meaning to your text. They can have connotative effects. So connotation, they put you in a style or in a context. For example, this is the classification of typefaces, and each type, each family has a connotation of being historic, classical, modern, and so on. And of course, you have a lot of creativity in this area. So here you have examples of creative typefaces. You have comics, you have machine-like style. And here the three first examples are called exotypes. So here you have one writing system disguised, mimicking another writing system. And here, in the three cases, you have Latin alphabet, jusqu'à quand abusera-t-il de notre patience? This looks like Hindi, Devanagari. This looks like Hebrew, and this looks like Japanese Kana. But in all cases, it's in fact Latin. And here, this is a picture I took some years ago of an Indian restaurant in Marseille. which wanted to use exotype font to imitate, well, Indian, but chose the wrong exotype and took this one. So in fact, it's a restaurant Indian restaurant, but using a Hebrew-like script. So this picture was taken in 2013, and here, 2 years later, the picture is from Google Earth, and you see they changed their sign. This time it's really this one, the first one. So it is an imitation of the Devanagari. They don't change it everywhere. Here you still have the Hebrew-like one, but at least they changed the main sign of the restaurant. So this was an accident. Connotation can be really part of meaning. Here on the left, you have the name of Bonn, the previous capital of Germany. Now it's Berlin, of West Germany, and in 3 different fonts. This is about politics, it's modern. This is about music, it's classical, and this is about history, romanticism, and Fraktur. And here, this is a political affiche where it says, go vote, others do it too. And the part talking about others is written in a broken script. So in fact, it's a hint to extreme right parties. So by using this, the font gives a precise political meaning to this second sentence, which would be completely lost if the same font was used for both sentences. So here, connotation becomes really part of meaning. In typographemics, there are other ways of injecting meaning, and this is a famous poem by Mallarmé, Un coup de dé jamais n'abolira le hasard, where words are written in a way with different sizes and on different lines and with different distances and positions on the plane that adds meaning by the graphic articulation of the text, by the movement of the eye in order to read the text. And this, of course, gets completely lost when the poem is recited. Apollinaire did a similar thing. He used graphical forms. So this is a poem called Il pleut. These are verses, and they form these lines of rain. And you have an interaction between parts of the image and parts of the text, which gives unlimited creativity. You have ASCII art. Here, there's much less meaning. You can eventually choose the symbols you use to represent the image, but most of the time it's meaningless. It's just a way of representing low resolution images. And you have word clouds, where the size, color, and position of words gets meaning from the context. Now, from typographemics, let us now switch to Cyanographics. So graphemics of the Chinese writing system. Chinese characters are drawn using 39 different strokes. These are called fundamental strokes. You learn them when you learn Chinese calligraphy. They are fundamentally different, and with only these strokes, you can draw all Chinese characters. And there's a very large number of characters, more than 100,000, and new characters are created every year. So here you have numbers, representations, names, and cases where they are used. Now, using these strokes, you build frequent patterns, which are called components. So these strokes are often used together. So these are frequent patterns, and with these components, you build characters. Now, some of these patterns exist also in individual form. And when I say exist, I mean more specifically that they are encoded in an encoding we all use called Unicode. So I call them subcharacters. Using subcharacters, I have done a classification of characters, and I obtained about 18,686 classes. And this is a representation of these classes. And the size of the characters is the number of outcoming arrows, an arrow being an inclusion of a subcharacter in a supercharacter. So these are the components which are used most frequently. This cloud represents all of these classes. Now, from a linguistic point of view, a Chinese character can be studied in this way. So this formal representation, we will see many formal representations in this class. This is one of them. It's called AVM, Attribute Value Matrix. So you have attributes, phon, sinsem, orth, sil, kat, sem, and you have values. And values can be submatrices. So the value of phon is this matrix, and this matrix has an attribute sil, which has again a value a matrix, and so on. Now, my main attributes are phon, phonetics, sinsem, syntax and semantics, and orth, orthography. Inside phon, I have syllables, and each syllable has a segmentation in attack, onset, and rhyme, and also a tone, because Chinese is a tonal language. Inside sinsem, semantics, I have a part of speech. So sorry, I forgot to translate this here. So this is part of speech, and this is semantics. And part of speech is noun, and semantics is seagull, cockroach. So this character has this phonetic representation, this tone, second tone, and it's written in two parts. You can see them, left part, right part. And the left part belongs to this meaning. So the left part has the meaning, seagull, and the right part has the phonetics given here. So as you see in this diagram, it's not just a tree of attributes of values, you also have links. And so I'm linking this leaf of my tree with this part, or with this other leaf, and this part with that part. So this means that in this Chinese character, you have two parts. horizontally placed. The left part carries the meaning of the character, and the right part carries the phonetics. So the right part says, how do I pronounce it? And the left part says, what does it mean? In fact, things are a bit more complex than that. And we call these two properties semanticity and phoneticity. So components of characters are more or less semantic, more or less phonetic. And here I have calculated the phoneticity expectation. So statistically, I take the expectation as calculated to probability, espérance, and what is the expectation of a component to be phonetic. And if it's not phonetic, then it's either semantic or gives no information at all. It's neither semantic nor phonetic. And as you see in Mandarin Chinese, I have a high phoneticity for the right part, if the character is of this form, two components horizontally placed, and a much lower part for a lower phoneticity expectation for the left part. Now, this property of phoneticity and semanticity is inherited by other languages using the Chinese writing system. So, for example, in Japanese, you have two ways of reading Chinese characters, on and kun. On is the pronunciation of characters that historically came from China, because when Japanese got the writing system from China, they also got the pronunciation of the characters. And kun is the reading of the character according to Japanese language as it pre-existed, so before the introduction of the writing system. And of course, on and kun are completely different, because Japanese and Chinese are two completely different languages. So this character, you remember, which means man, will be ren in Chinese, so with first tone, nin in Japanese on, so ren, nin are not very different. So this is an adaptation of Chinese phonetics to Japanese, and hito, so something completely different in Japanese kun. When this character is used inside that character, so this is what you see on the left of this character. It's the same component. And this means to carry a weight. And the pronunciation of this character is taken over by this one. So in fact, the left component gives the pronunciation of this character with a small difference, the difference of the tone. Here I have a first tone, and here I have, I think, a third tone. In Japanese, Japanese has no tones. It's exactly the same. In Japanese on, in Japanese kun, of course, the words are completely different. So now you understand the meaning of this slide. It's to say that the fact that the left part is phonetic is inherited by Japanese. Sometimes it's even stronger in Japanese because of tones disappearing, and only in Japanese inherited from Chinese. In real Japan, in historical Japanese, it's not the case. Now, playing with phoneticity and semanticity is very creative in Chinese, especially when one wants to write foreign words. So here is the case of Coca-Cola. Both in Chinese and Japanese, we want a way to write something which would be pronounced Coca-Cola or something close to Coca-Cola, something recognizable. But this is the phonetic part. But these characters also have semantics. So we can choose semantics that are appropriate to a beverage. So what I want to show you is that in these languages, you have the possibility of adding an additional layer of meaning together with the phonetics, and the phonetics give you the meaning of the product. So the product is Coca-Cola. This is the first meaning, and then the second meaning, secondary meaning, is the one given by the semantics of the characters you use. And here is what has been chosen. So you recognize these characters. They are used both in Chinese and Japanese. And in Chinese, the meaning of these two is delicious, and the meaning of those two is cola pastry. So it's very close to the actual referent, which is the beverage Coca-Cola. And in Japanese, it's mouth and pleasure. So it's a singing pleasure. Okay. And this is the choice of the company Coca-Cola in China and Japan to use these characters. So in order to carry this additional meaning out of the character meaning. Now, how do we deal with Chinese characters? They are, of course, encoded in Unicode. We will speak about Unicode in a moment. But there is another way of describing them, which is the CDL format. CDL means Chinese Description Language. It's written in XML. You have an element for each character, and sub-elements will either point to components. So this component here is described here, or will use fundamental strokes. So you have on the internet data describing all Chinese characters, so all characters present in Unicode, no more than 100,000 characters. And this description is hierarchical. It starts with components, and if you continue looking into the sub-elements, you arrive to fundamental strokes. But of course, each time you need what we call a bounding box. You need a box to place your components so that they occupy exactly the correct position and have exactly the correct ratio and size. Now, the advantage of this system is that you can describe any character, including characters that don't exist. So this is a long history in Chinese typography. What do you do when you're missing a character? Because you have to print a document which has a very rare character. So what they did is they first put a generic character, so a black glyph, which would be proeminent. So editors would immediately see that something is missing, and they ordered the missing character from a specialist who would engrave it. And this, of course, took a lot of time. Nowadays, characters are placed in fonts. If a character is missing, then you have to draw it. And to draw it, you have to describe it because there are algorithms for drawing characters out of descriptions. And here, the slide shows you a possible description. So this can be used to describe non-existent characters or characters that just have been created. Now, if you think that it's very seldom to find non-existent characters, the same artist, Xu Bing, who wrote that book with the pictograms, also did a piece of art where you have tens of thousands of non-existing Chinese characters. So he filled a room with non-existing characters so that Chinese or Japanese people, native speakers, would feel completely disoriented by not understanding what they are seeing. Okay, so now we switch to a very important topic for you. How is graphemics handled by computers? Now, the terminology already is a bit different. In computing, graphemes are called characters and graphs. So remember, the graph is the material side. It's the shape, the drawing, the image. And graphs are called glyphs. Now, characters are abstract notions. They live in files or in data streams. They can be identified by numeric values. We will see how. And glyphs are images, and glyphs live in fonts. Fonts are also called typefaces. In French, police de caractère. And of course, when you say police de caractère, it's a terminological error because this police don't have character, but glyph. But okay, it's an error. Now, characters are abstract objects, and when they are sent to a screen or to a printer, then the system will replace them by glyphs, by images. And so you can, like now, you can read on your screen or on paper. And we then say that the characters are rendered. Glyph rendering can be a complex process. So take, for example, a meme, a ha, a meme, a shadda, and a dal. Once these are composed in the sense of compositionality, you get the word Muhammad, and you render it like this. So you see that these glyphs change shapes, and from horizontal composition becomes partly vertical. Meme is above ha, which is above the other meme, and the shadda is somewhere up. This process can be quite complex, and it is done by the font. So fonts are nowadays very intelligent to be able to handle different rendering processes. Now, characters, this is the abstract part, characters are identified by numbers, and these numbers are what we call slots in an encoding. So an encoding is a correspondence between positions, slots, numbers on the one side, and on the other side, the abstract information of a character. So when I say Latin letter A, this is a character. Its position in ASCII or in Unicode is 65. So the number 65 represents the character Latin letter A, Latin capital letter A. And Unicode is the most widespread encoding. Unicode started in 91. Nowadays, we are at version 13 of Unicode, and it grows every year. It has, as you can see, more than 1 million slots, but these slots are potential characters. They are not all occupied. And they are divided in 17 planes of same size. Not of all of these planes are occupied. The most important for us is the basic multilingual plane. And then we have another plane with more seldom writing systems, ancient writing systems, and so on. Another one only for Chinese characters. There are already a lot of Chinese characters in the B and P, but there are even more of them in the SIP. And then the two last planes are called private use planes. So a company, a corporation can say, we will use these positions for our specific characters, and this is only for us. So here you have the possibility to define your own characters. And this is a graphical representation of the different planes, and we will deal mainly with the basic multilingual plane, the first one. When you go to the Unicode website, unicode.org, you get access to what is called the charts. The charts are tables having a graphical representation of each character, and also lists like this one. So in this list, you can see the position in hexadecimal. You can see a glyph representing the character. And in capital letters, you have the identity of the character. So this is very important, it's unique for each character. And it's description, but it's formal description. And then you have properties like saying that this character is equivalent with some other characters, that it has some special names, and also that it shouldn't be confused. So for example, this is a German SZ, which you shouldn't confuse with the Greek beta, which is a different character. Same thing here, you have a character Macron, which is not our president, it's just a character which pre-existed before Republic of March. And it's this diacritic, so it's a bar you place over letters to show that they are long. This is a degree sign, which is not the same thing as the ring operator in mathematics and so on. Now, to use Unicode in an efficient way, you should be aware of the Unicode principles. There are 10 of them, actually 11. So the 10 official principles of Unicode are, first of all, Unicode is interested in all writing systems. Unicode is easy to analyze and to process. Now, how should we understand this? Before Unicode, there was a system called ISO 2022. And many encodings called ISO 8859, 1, 2, 3, 4, and so on. So some of you may have heard of ISO Latin 1, ISO Latin 2, ISO Cyrillic. These were small encodings with only 255 slots. And one of them was for Western European language, another one for Central European languages, another one for Cyrillic, another one for Greek, for Hebrew, for Arabic, and so on. Now, when you have many small encodings, it means that the same position has a different value, different semantics in each of these encodings. If in a text you have to combine them, so in a text you have a word in French and then a word in Russian and then a word in Greek, you have to change encodings. Now, this can be done by what we call high-level markup, but it can also be done with low-level markup, and ISO 2022 was a system for switching from one encoding to the other, and the means of a finite state automaton. So each encoding is a state, and you have transitions from one state to another. We will see finite state automata later in this class. Now, from a computer science point of view, if you know in which encoding you are located, then you have no loss of information. You know, now I'm writing French, now I'm writing Russian. But from a human interface point of view, this would be disastrous, because imagine you have a window on a human phonographical human interface, and you want to copy and paste some text. When you copy it, you lose the information on the state, so you don't know in which encoding you are located. So when you paste it, it comes out as something different. So the idea of Unicode was to keep this information. And of course, this cannot be done with small encodings. You need a large encoding. And this is why Unicode has so many characters. Third principle, Unicode encodes characters and not glyphs. So if you take letter A, be it in italic or bold or Times or Palatino or Universe, it's always the same character, Latin letter A. But between the capital and the lowercase letter, you have different characters. So there's a distinction between glyphs, which are all merged, and characters depending on each language. Characters have well-defined semantics. I have quoted semantics because it's not really semantics, it's just an identity. Unicode encodes raw text, so no italics, no bold. And the default order of characters is logical order. Well, so logical is the term used by Unicode. In fact, it's phonetic order. So for example, if you have a mixture of French and Arabic text, phonetically, phonemes have only one order, which is the temporal order. So if I write a word in French and then a word in Arabic, and if I render this phonetically, so if I pronounce it, there will be an order of phonemes. So this order of phonemes, the temporal order of phonemes, is the logical order in which the information is stored in the computer. Out of this, then the rendering engine must find the order of the glyphs, and glyphs in Arabic are written from right to left, in French from left to right. Okay, so we separate these two problems. We have the logical order, which is the same for everybody. The logical order is neither right to left nor left to right, because in the memory of the computer, there is no right or left. It's just logical, which byte comes before the other byte. It's the address of the bytes. The seventh principle is unification. A unification means that you have Chinese character used in China, in main China, in Taiwan, other places, in Singapore. You have Chinese characters used in Japan, in Korea. Well, all of these are merged. Even if they are slightly different, Unicode will merge them. And this unification is the prefix uni of Unicode. And of course, nobody was happy with this operation of merging, but it was useful to keep the number of Chinese characters in limits. Now, dynamic composition is a very useful property when you want to combine characters with diacritics. So, for example, you have a letter A, and you want a circumflex accent and also an acute accent and also a dot underneath it. You will write the letter A and then what we call combining characters, one for each diacritic. The same thing is used in Arabic for short vowels and diacritics. So you will write a letter, sheen, followed by a fatha, and then a shadda, and so on. Equivalent sequences, from the moment where you can write the same character, letter A with circumflex accent, A accent circumflex, you can write it in two ways. One is as a single character and the other is as a base character followed by a diacritic. These two sequences must be considered equivalent. Otherwise, software doing sorting and searching will distinguish them. So we have this notion of equivalence. And software must be able to merge equivalent sequences. And finally, the 10th principle is convertibility without information loss, in the sense that all the encodings that existed until 1993 have been imported into Unicode. So all the strange or useless or eccentric or bad characters that existed in encodings exist also in Unicode. For example, in the North Korean encoding, you had special characters for the name of the supreme leader, for the son of the supreme leader, for the nephew of the supreme leader. So all of these characters, which were useful only in North Korea, unfortunately exist in Unicode because of this principle. And then the 11th, what I call the 11th principle of Unicode is invariance. So nothing changes. Once a character has been defined, you can either change it nor remove it, nothing. It will change, it will stay forever. And here I have an example of how stupid this is. This is in a table of Byzantine musical symbols. And these symbols are called phthora. Phthora is written F-T-H-O-R-A. It's one way of writing this Greek word. Doesn't matter. It's identifiable, so it doesn't matter how it is written. And here for this character, that word, which is exactly the same word as the others, has been written with a spelling error. The H is written before the T. So this is typically the error of somebody typing these names. Instead of correcting this error, Unicode has added a note saying, we know that it's misspelled, it's a known defect, so we are not going to change it. We don't correct errors, we leave them. Now, more seriously, you have different information strata. So as engineers, you should be aware of these strata because many problems in text processing come from incompatibility of these strata. So the first layer is, for each character, the first layer is its description. When I say Latin capital letter A, I describe a character. And this is unique and unambiguous. The next layer is the slot. So what is the number of the position of this character? So in this particular case, it's 65. Now, up to the second layer, I have only abstract information. Now, starting with the third layer, I'm interested in the computer representation in memory of this number 65. And the third layer is the representation in computer memory. So am I using UTF-8, UTF-16, and so on? I will show you what UTF-8 is, but in fact, the question is, am I using 1 byte, un octet, 2 bytes, 2 octets, 4 bytes, and so on. The fourth layer is, in which order are my bytes? Now, between Microsoft and the rest of the world, you have 2 different byte orders. In the rest of the world will use what we call big endian. So if you have 2 bytes to be combined, the big one, the small one will come first and then the big one. So it's big endian. Microsoft will use little endian. So the big one first and the small one afterwards. So this is really about how the information is stored either on disk or in a stream. And the fifth layer is transfer. So can I really transfer bytes, or must I encode them in some other scheme like hexadecimal, base 64, and so on? The most important layer for us is the third one. So here's an explanation of UTF-8. You all have heard of UTF-8. So what is it exactly? It's an invention by Ken Thompson, the inventor of C and Unix, co-inventor of Unix. And the idea is to be economic on the number of bytes needed. Because for English, 1 byte is sufficient. For French, 1 byte is sufficient. If we move to other scripts like Indian scripts or Arabic, then we need 2 bytes. And if we move to rare scripts like ancient script, hieroglyphic, and so on, then we need 4 bytes. From these 4 bytes, most of the information will be 0 because only a small part of the 4 bytes is used. Now, if software has to read text, it must know if it will read single bytes, pairs of bytes, or 4 bytes in a row. And if we use 4 bytes in a row, then it means that our files will be multiplied by 4. The size of our files will be multiplied by 4. So there will be a lot of empty bits. The idea of UTF-8 is to say, I'm using a variable length. So each character can be encoded in 1, 2, 3, or 4 bytes, depending on how many bits it needs for its representation. And so, for example, characters between 0 and 127 will use a single byte, and here are the bits actually carrying information, and the 0 says that this is a single byte character. Then if we need more information, like in French for accented letters, we will use 2 bytes. In these 2 bytes, we first have this sequence of 1, 1, saying that 2 bytes have to be read. And then we have a 0 and useful information. Same thing when we have even more information, then we need 3 bytes. And at most, we will use 4 bytes. So, and that's the meaning of UTF-8. Using Unicode in programming languages, some years ago, it was necessary in Python to use this prefix U in front of a string. Now I hear that it's not necessary anymore. It's by default Unicode. You can always use this to be sure that the bytes of your file are understood by Python as UTF-8 characters. When you read data, you can use this library, IO, and it has this named attribute encoding. You can set to UTF-8. This is for Python. And Perl, you need this pragma to use UTF characters in your code, and you use bin mode to specify the encoding for reading and writing. And for other languages, there is this page with a lot of details on how to use Unicode in all languages, including C. Now, we still have 15 minutes. And I'm starting a new section, which is morphology. So now the idea is to take either phonemes or graphemes and to compose them. Composing meaning concatenating them either temporally as sound waves or graphically on the page. And out of these will emerge meaning. So I will use a new object, which I would call a morpheme. And the morpheme will be the minimal amount of meaning which occurs when I combine either phonemes or graphemes. Now, here is an example where I have the phonetic alphabet. And this can be seen both as writing a phonetic alphabet or as a sequence of phonemes. You can imagine hearing this. When you have a stream of phones, a stream of sounds, you don't know in advance where to segment the stream. Now, what you can do to segment a stream is to find frequent patterns. So for example, here you have a pattern, then. Are the other patterns? Here you have something looking like this. And by detecting these patterns, you already get some structure. Now, in these patterns, you see some sub-patterns which are repeating. So for example, here, this ends with an O. And this one ends with ete. We can segment according to these patterns. And then we can mark these suffixes. So these are always at the end of our segments. And what we are doing here is actually a morphological analysis. So we are segmenting a stream of either phonemes or graphemes in words, and words are segmented into morphemes. And this is what you're actually seeing. So here, of course, it's much clearer for the native reader, and you see that these suffixes which are similar, they have a morphological role. So this shows that we have a verb, while and this is also a verb, while this here shows that I have a noun or adjective and so on. So the idea is to take minimal units of meaning as concatenations of either phonemes or graphemes. And these minimal units of meaning are called morphemes. Now, every language uses morphemes. Doesn't matter how they are written, how they are pronounced, we always have morphemes. And there are at least two kinds of morphemes, those called lexical or free morphemes, and those called grammatical or bound morphemes. Now, free morphemes are many. They carry lexical meaning. So if I say table, chair, door, these are morphemes. There can be many of them. I can invent new ones. I can take some from one language and move it to another. For example, in French, you have the verb spoiler, you have likes, you have buzz, English words used in French, and the other way around. In England, in English, you have many French words. So these are lexical morphemes. There are many of them, and they carry meaning directly. Bound morphemes, first of all, do not exist in isolation. For example, you have the S of the plural in French, and also in English in many cases. So this S will never appear alone. It is added to a lexical morpheme to add information. So here it is information on the number. Here you have the suffix of a verb, and it's the third person of plural of the future of this verb. Now, in some languages, free and lexical morphemes are written in different systems. So for example, in Japanese, lexical morphemes are written in Chinese characters. Yes? No, okay. So lexical morphemes are written in Chinese characters. And particles, which are bound morphemes, use hiragana, so a syllabic writing system, especially for these particles. And here you have La vie est un long fleuve tranquille. Life is a long and quiet river, written in Japanese. In morphology, we study also transformation of words. So transformation is mostly take a lexical morpheme and add different grammatical morphemes to it. One kind of transformation is inflectional. So inflection means either to decline or to conjugate. For example, for nouns, you can have different numbers, singular, plural, in some languages dual. You can have different gender, masculine, feminine. In some languages you have also neutral. In some languages you have case. And for verbs you have person, mode, voice, and tense. And also a number, I forgot the number. Each language has its own configuration. So in French, you have two numbers, two genders, but no case. And you have agreements. So the grammatical morpheme of a verb will agree with the grammatical morpheme of a noun, and if it's the subject of the verb. Donc, un enfant marchera, des enfants marcheront. In German, you have numbers, genders, but also four cases: nominative, genitive, dative, accusative. In Greek, you have 5 cases and 3 numbers, because you also have dual in ancient Greek. In Russian, you have 3 numbers, 6 cases. In Arabic, you have 3 numbers. And in Arabic, the verb also agrees with the gender. So the verb will take a different form according to the gender of the subject. In Finnish, you have numbers, 2 numbers. You have no gender. So this doesn't mean that there are no female and male Finnish. It means that words do not carry information on gender, but you have many cases, 14 different cases. And in Japanese, you have only particles. So you see that some languages seem more complex than others, but in fact, it's the same complexity always, but distributed in different ways. Besides inflectional morphology, you have derivational morphology, and this is much more open. Derivational morphology is the creation of new words using rules of grammatical morphemes added to verbs. So, for example, from table to tablette, table, tablette, something smaller, marche, démarche, mange, mangeable, so eatable, and here are some of the mechanisms. You can add a suffix, manger, mangeable, prefix, tirer, retirer. You can compose, canapé-lit, casse-noisette, avant-hier, après-midi. You can construct sigla. You can truncate, au lieu de sympathique, sympa, au lieu de psychologue, psy. You can use what is called portmanteau, so words are merged. So motor, hotel gives motel, smoke and fog gives smoke, smog. French and English, Français, Anglais gives franglais, and so on. And you can reduplicate, fille, fille, père, pépère. So these are just some of the existing mechanisms. Now, why is it useful to detail all of this? Because a machine has to be aware of these mechanisms, both for recognizing words and for creating words. So you cannot possibly put all of these cases, all of the occurrence into the memory of the machine. The machine at some time will have to create these or understand some of them which are not in its lexicon. And this can be done with rules. And generic and morphological mechanisms can be described by, for example, finite state automata. So here I have the finite state automaton, which will describe cases with a, masculine, feminine, plural, plural of the masculine, plural of the feminine, and able. So with this finite state automaton, I can recognize calcul, calculer, calculer, féminine, masculine, plural, singular, calculable, calculable, singular, calculable, plural. And the same automaton can be used for vérifier, vérifiable, gérer, gérable, traiter, traitable, perturber, perturbable, and so on. So this can simplify processing of a given language once we know the morphological rules. And this is especially useful for Arabic, which has a very special, very nice morphology based on two notions, the root and the scheme. So the root, which we find also in Hebrew and other languages, is a collection of strings of either 3 or 4 consonants, sometimes they are weak. And these consonants are used in semantic domains. So for example, kataba is used in the domain of writing. So you have kitab, the book, katib, the author, aktubu, I'm writing, maktub, the office, and so on. Fa'al in the domain of action, qaraba in the domain of proximity, and so on. So you have thousands of roots, which all can be used for inflectional or derivational transformations. And you can even add new roots, like, for example, for the French word film, FLM, filim, aflamu, and so on. And these roots are combined with schemes. So schemes are patterns of short or long vowels or absence of vowels or even other consonants which are placed between the letters of the root. And by combining a root and a scheme, you can obtain hundreds of different forms. And here I have just a few examples. So I will stop here with morphology. We will continue next time. And we have seen today the principles of linguistics, phonology, graphemics, and we started dealing with morphology. Now, as I said, on Moodle, I have 2 questions. So let me share my screen. So this is the Moodle page of the class. This is our program. And here are Zoom links. I will add those for the forthcoming sessions. And here are the slides you have seen today. And here are the 2 questions which I would like you to answer before the next class. They are not evaluated, but they can be very useful for you. Do you have any questions? Okay, so I will stop.